This is objective 7.2a, and it's all about right triangle trigonometry. So today we're just going to focus on the 6 most popular and basic trigonometric ratios. And when we're done, you should be able to explain to me the relationship of the six trig ratios to the angle theta and their relationship with each other. Yes. It's frozen. Thank you. Is it unfrozen?
No.
How about now? Okay, thank you. Thank you. All right. So if you recall, back in freshman year, sophomore year, you learned 3 trig ratios that had to do with an angle measure. And these were sine, and you learned the acronym SOHCAHTOA. Sine is opposite over hypotenuse. And then cosine, ka, is adjacent over hypotenuse. And then toa, tangent, is opposite over adjacent. Now, some people just write it out as one long word, SOHCAHTOA. I like to stack the 2 letters, opposite over adjacent, just so that it's just a visual to remind me of the placement of each thing. I think you do it however it makes sense to you. So let's review how we decide we're going to choose sine or cosine or tangent, because you do have to make decisions. So let's go over here to this right triangle. Remember that these all work with right triangles, not acute triangles or obtuse triangles. And let's go ahead and put angle theta down here in the right-hand corner. So angle theta is very powerful. I have to look at this triangle from the perspective of angle theta. So when I'm doing trig, I will always put my eye. So I'm going to draw a little eye right here on angle theta. That's my perspective. I'm looking at this triangle from that angle, and I will quickly label it. Opposite is the side it's looking at. It's opposite. It's the side that theta is not touching. And then adjacent is the leg that is touching angle theta. It's next to, adjacent means next to. And then, of course, the hypotenuse is also always opposite the right angle. Okay, so if I move angle theta, let's go with a different color. Say I put angle beta up here. So if I want to know angle beta, I have to move my eye's perspective over here. Well, what does that do to my opposite and my adjacent? It switches them. So it's really important to remember to start with the angle that you're either given or the angle that you have to find, and then you look at the triangle from that angle's perspective. That's really important. We're going to focus on angle theta today, not angle beta, okay? All right, so everything's off of angle theta. So over here, the basic trig functions, or the trig ratios that you already know, are sine, cosine, and tangent. Today I'm going to introduce to you their reciprocal functions, and I think I'm not going to write it that far out. Let me scoot it in a little bit. So the reciprocal functions, okay? And reciprocal is not the same as inverse, okay? Reciprocal means that the ratio flips over. The numerator and denominator switch places. That's not inverse. That's reciprocal, okay? So the basic trig functions are, I'm going to start with my green pen, sine. So the sine of theta is equal to, we know this, opposite over hypotenuse. And we can use our acronym. Is that an acronym? What do you call that? Not an acronym, is it? Yeah. Isn't it a mnemonic? Yeah, it's a mnemonic. Mnemonic, SOHCAHTOA. Acronyms like a shortened version, like if I want to write international and I write, I don't know. Forget it. It's a mnemonic. It's a mnemonic. Okay, so sine has a reciprocal function. Its reciprocal function is cosecant of theta. And I'm going to come over here and just spell that out. Cosecant is spelled C-O-S-E-C-A-N-T. And you might wonder why that's important to know that. Well, when you're in calculus and you're deriving a sine function, you might need to switch to its cosecant function. So cosecant of theta is related to sine of theta in that they are reciprocal functions of each other. So here's the problem. With cosecant of theta, your calculator doesn't have a cosecant button. So what do you type into your calculator if you're given cosecant of theta? Here's what you type in. You type 1 over the sine of theta, right? That's the reciprocal of sine of theta is sine of theta over 1 over sine of theta, right? Yeah. So if I'm given cosecant of theta and I have to plug something in my calculator, I can't. So I'll put 1 over the sine of theta and I'll get the right answer. But that's not helpful for what we're doing today. This is just making things complicated. So let's do a little bit of a conversion here. So that means it's 1 over sine of theta, which is opposite over hypotenuse. But that made it even worse because now we have a complex fraction. So I'm going to keep change flip 1 times hypotenuse over opposite. Look at that. Reciprocal functions. Instead of opposite over hypotenuse, you have hypotenuse over opposite. So that is how they're related. They're reciprocals of each other. So if I want cosecant, I want the hypotenuse in the numerator and the opposite side in the denominator. Next, we have the sine of theta. Oh, and I'm doing this in red. Sorry. So the sine of, no, not sine, cosine. Oh, I've taught this lesson so many times today, my brain is fried. All right, mushy. Cosine of theta is, using your mnemonic, ca, adjacent over hypotenuse. Awesome. It has a reciprocal function as well. Its reciprocal function is secant of theta. So secant is spelled S-E-C-A-N-T. Okay, and the secant of theta, we can't find that with our calculator. So what would I type into my calculator if I'm trying to find secant of theta? 1 over cosine of theta. Beautiful. But that's not going to help us today. So we're going to replace cosine with adjacent over hypotenuse with its equivalent value. And then let's get rid of the complexity. Keep change flip 1 times hypotenuse over adjacent. So hopefully you can just, I think you probably would prefer to just flip over adjacent and hypotenuse, right? Absolutely. All right, last one, basic function. And sine and cosine are the really basic one. All of the other functions are built around sine and cosine because tangent of theta, using your mnemonic, is opposite over adjacent. Okay? And its reciprocal function is a little bit easier to remember. It's the cotangent of theta. So COT is cotangent. And remember, you only ever write, when you're writing sine, cosine, tangent, you only ever write the first 3 letters of, well, except for cosecant, because if you write cosecant, the first 3 letters, you'd be writing cosine, right? Because cosecant and cosine start with COS. So be careful about that. So the cotangent of theta, I'm given the cotangent of theta. I got to plug something in my calculator. I would plug in what? 1 over tangent of theta. I have to because my calculator doesn't have a cotangent button, which is the same as 1 over opposite over adjacent. You tell me, fix that. Adjacent over opposite. Now, if you want to, you can come up with your own mnemonic to help you remember. Cosecant is hypotenuse over opposite, secant is hypotenuse over adjacent, and cotangent is adjacent over opposite. You can come up with a mnemonic if you want. That might be helpful. But I think if you just really drive home the idea that they're reciprocal functions, cosecant's the reciprocal of sine, then you can just reciprocate opposite over hypotenuse. Just flip it over. It's up to you. I will tell you that students often want to match sine with secant because they start with the same letter, and cosine with cosecant. Avoid that. Okay, this stuff you need to commit to memory because you want it to be easily accessible. So I gave you a lot of practice problems today because I want you to remember it. And I believe that on your homework, if you really want to remember it, you should color code the way we're doing this in notes. I think that extra connection on your paper and visually with your eyes is going to help your mind remember it better. That's just my advice. You do what you do. Some of you have memories like elephants and you remember everything. I tell you once and you remember it. Okay, so here we go. We have an examples today where you're asked to find the exact values of the 6 trigonometric functions for angle theta. I gave you a bunch of blank triangles with nothing on them. We're kind of stuck until I give you some values. So pick up your pencil. Let's go ahead and put the right angle mark in that triangle, and let's label its sides. This is short side is 5. This long side is 12, and the hypotenuse is 13. That's a 5, not a 6. Let me clean that up. All right, and let's put angle theta down here in the bottom right corner. So here's my perspective. If I'm going to write the trig functions that go with angle theta, I put my eye right here on the triangle. So I'm looking at the triangle from this perspective, and I label it. So 12 is opposite, 5 is adjacent, and hypotenuse is always the easy one to find, right? Because it's always the same. So we have to make sure that we don't want to get our sine and cosine mixed up. Okay, because angle theta and angle beta switch opposite and adjacent. So I'm going to start with my green pen. And I'm going to start with finding my basic sine function. So sine of theta. I'm going to ask you to give me its exact value as a ratio. So I'm talking about as a fraction. David, what's the sine of theta? Use your mnemonic. Sine is opposite over hypotenuse. So what value should I plug into my fraction? 12 over 13. Beautiful. All right, so let's immediately go to sine's reciprocal function, which is, don't tell me the reciprocal of 12/13. Tell me what the reciprocal function to sine is. Cosecant. Cosecant of theta is, now tell me the reciprocal. 13/12. Okay, so that'll be easy. It's just remembering which ones are the reciprocal functions. Switching to red, and we're going to go to cosine of theta. All right, cosine of theta. Jordan. So what are my values? Beautiful. All right, everybody together, what's the reciprocal function of cosine? Secant. Beautiful. Secant of theta is 13/5. I like it. Switching to blue. Tangent of theta. Let's go with Marco. So that is 12 over 5. And its reciprocal function is cotangent. So our measure is, everybody? Or our ratio is 5/12. There you go. So while that's not too bad, I'll challenge you a little bit on this next problem. All right, so let's go to the next one, unless you have questions. Are we good? Okay, don't go to sleep on me. All right, so here we go. Here's your right angle. And what we're going to do is, let's see, which I'm going to do this bottom left-hand corner as angle theta. And I'm going to give you the measure of this side, which is 6, and the measure of this side, which is 8. And that's all I'm going to give you. And I'm going to ask you to give me the 6 trig functions. Well, let's label it. So here's my perspective. So 8 is opposite or adjacent? So 6 is, and we are missing the, what could we do? Ooh, the Pythagorean Theorem, I heard it. Hopefully soon you will memorize that this is a 6, 8, 10 right triangle, which is part of the 3, 4, 5 right triangle family. But we're going to use the Pythagorean Theorem like you suggested to prove that the hypotenuse is the measure 10. Okay, so we're going to do 6 squared plus 8 squared equals, not c squared, people, hypotenuse squared. You are not in geometry. You are in pre-calculus. Okay, so that's 36 plus 64, which is 100, equals hypotenuse squared. Square root? What's the hypotenuse? 10. I'm wondering if yesterday on your ACT you came across a 6, 8, 10 right triangle. I see them on almost every ACT. Sometimes it'll be a 3, 4, 5 instead of a 6, 8, 10, or some version of the 3, 4, 5. Listen, this set of measures happens often in right triangles. And all of the sides are perfect integers, no fractions, no decimals. All right, so now we can do what we need to do. So our sine of theta, Devin. True, but I would probably want a little more than that, because I think that can be simplified. 4/5. All right, there we go. I do expect you to simplify all your fractions, all your radicals, everything. And what is its reciprocal function? Cosecant. Cosecant of theta is 5/4. You got it. Switching to cosine. Cosine of theta. I'm red. All right, Brayden. So you reduced it in your head. 6 over 10 is 3/5. Beautiful. What's the reciprocal function of cosine? Secant. Secant of theta is? I love it. Okay. Tangent of theta. Let's see, Reno. Reduce? 4/3. Beautiful. Cotangent of theta. Everyone? What? 3/4. That wasn't everybody. Oh, thank you. All right. Not too bad. A little bit of Pythagorean Theorem and some other things that we know how to do. So we're just putting some things we know how to do together. All right, now I'm going to really complex it up. You'll survive. I promise. Oh, don't start singing songs. Okay. I'm going to put angle theta up here. And I'm going to give you the measure of this side as y. And the measure of this side as x. And that's all I'm going to give you. And your algebra skills are going to have to come into play. So we're going from angle theta's perspective. So side x is the opposite. This side adjacent is missing. And our hypotenuse is y. All right, first thing we need to do is find adjacent. Now, I changed it from A and C to X and Y so that you do not feel like you need to label adjacent as B, because that's what we do with the Pythagorean Theorem, right? We usually label one of the legs A, one of the legs B, and the hypotenuse C, but that's confusing a lot of people. So listen, we're going to find the adjacent side in terms of X and Y. No other variables are going to be introduced when you do these problems. So we're going to find adjacent. We need to. So you can use the Pythagorean theorem or the modified Pythagorean theorem. The modified Pythagorean theorem says this, and you might want to write this over here. Here's what we know if we go back to the basics. A squared plus B squared equals C squared. True statement. Leg squared plus leg squared equals hypotenuse squared. But sometimes we don't have to find the hypotenuse. Sometimes we have to find a leg. So modified would be C squared minus A squared equals B squared, or C squared minus B squared equals A squared. It's just depends. So when you have a hypotenuse and a leg, and you need to find the other leg, subtract C squared minus A squared. So here's what we have, right? We have the hypotenuse and a side. So I would say y squared minus x squared equals adjacent squared. And I want to keep adjacent in terms of x and y. Don't introduce a new variable. So how do I get adjacent? I can't add these. They are not like terms. So how do I isolate adjacent? I have adjacent squared. Square root both sides. So I'm going to say the square root of y squared minus x squared is equal to adjacent. And some of you have a really bad habit of thinking that this is y minus x. It isn't. Remember that this is the difference of squares. So I come over here, and if I go y squared minus x squared is equivalent to y minus x times y plus x. Those are not duplicates of each other. It's not a perfect square statement. So that's as far as you can go. And so I'm going to label it in a color so we know that it wasn't an original part of the problem. The adjacent side in terms of x and y is the square root of y squared minus x squared. So be really careful when you're working on your homework tonight, not to introduce another variable. Okay, so back to our green pen. We're going to start with our sine function. So sine of theta, let's see. Joseph, go. Beautiful. All right, everybody, what's the reciprocal function? Cosecant. Cosecant of theta is y over x. All right. Switching to red pen cosine. Cosine of theta is, let's see, Wyatt.
Square root of y squared minus x squared over y.
Beautiful. And our reciprocal function is? Y over. No. Reciprocal function. Secant of theta. And our reciprocal is?
Y over y
squared minus x squared. Okay, your teacher is on high alert that is not the right answer. It's not wrong, but it's pretty typical when you have a rational or a radical in your denominator to rationalize it and push the radical to your numerator. But I'm not going to ask you today to rationalize. Okay, so we're going to go ahead and be okay with that today. But know that typically I am not going to be happy if there's a radical in your denominator. All right, but it's okay today. Let's go to tangent of theta. Here we go. So the tangent of theta, Elizabeth. Okay for today, but again, there's a radical in the denominator. All right, so cotangent of theta, everybody? I like it. Okay, so there we have that. Tomorrow I'll talk more about rationalizing your denominator when we're actually plugging in values. Okay, all right, last problem. It's a little bit different. You're actually given one of your values, your cosecant, right? So I'm going to come over here and do my cosecant right now. My cosecant of theta is 24/25, which means I also already know my secant of theta, which is 25/24. But that's it. Now remember that cosine is adjacent over hypotenuse. So what I don't have is opposite. So a couple things you could do. You could think about that conceptually in your mind, or you could draw a triangle, right? And so I'm just going to draw a right triangle here. And this long side I'll make 24, and the hypotenuse I'll make 25. And I'll just ask you to be really careful. Think about your placement of angle theta, because now you have to think about it. It's not given to you. Where does it go? Bottom left or top right? Bottom left. Because remember that this is adjacent. Cosine's adjacent over hypotenuse. So guess what you got to do to find opposite? Modified or original? Modified. So we would do 25 squared minus 24 squared equals opposite squared. Remember, don't introduce any new variables. Well, that's 625 minus 476. I don't know. The difference is 49. I forgot what 24 squared was. Oh, you know what? I don't do 24 squared often. So, and my brain's 46 years old almost. So 49 is opposite squared. Square root, opposite is 7. So this is another what we call Pythagorean triple, because all our sides are whole numbers, integers. All right, so now we can go on to finish this problem. Let's grab up our green pen and find our sine of theta. So let's see, Brendan, what's our sine of theta?
7 over 25.
There you go, opposite over hypotenuse. And cosecant, everybody. Thank you for participating. All right, tangent of theta, we're almost done. Woohoo! Jose, tangent of theta.
7 over
All right, and cotangent of theta, everybody.
24 over 7.
So, hopefully now you can explain the relationship between the 6 trig functions and angle theta and their relationship to each other, the reciprocal functions. Okay, your homework, I'm going to say it on the video again, just for the people that aren't here, are 7.2a. You're going to do 1 through 8 all, and 15 through 20 all. I do also want to remind you quickly how to simplify radicals. If I give you the square root of 8, I'm going to tell you that's not simplified. So how do I simplify the square root of 8? The biggest perfect square. And 8, which is 4. 4 times 2. And what's the square root of 4?
2.
So 2 square root of 2. Okay. Also, you might have to simplify something like this. A square root of 2 over A. How do you simplify that?
Cross out the edge.
Or what if you have 2A square root of 3 over 4?
5.
Well, I don't have to give it. Do I have to give it some love? I don't think I can divide that by 4. But 1. So A square root of 3 over 2. So just make sure that you're reducing and simplifying your fractions and simplifying your radicals. And there we go.